Let's look at a few more examples of simplifying rational expressions. In these examples, we'll look at situations that arise when you have a negative in the fraction. Before we do that, let's go ahead and remind ourselves that having a negative fraction can be written three different ways. One way is you can have the negative right out front of the fraction. Another way is that you can have the negative in the numerator of the fraction. And a third way is to have the negative in the denominator of the fraction. All of these are equivalent, and it really is up to you where you want to write it. There are advantages, though, of recognizing that you have the negative in one of those three places and being able sometimes to move it from one to the other for convenience sake. The thing to remember, though, what is not equivalent is having the negative in both places if you want the fraction to represent a negative number. So negative 3/2 is not equal to negative 3 over negative 2. That is a false statement. So that is not something you ever want to work with. Let's look at the following examples. One thing to remember when we talked about factoring is it's always better to write an expression such that it's in descending order or in the same order. So in our first example, 3 minus x over x minus 3, the numerator is not written in descending order. So let's change that so it is. Instead of having the negative x second, we'll put negative x plus 3, so it's written in descending order, and then x minus 3. You'll see here that that negative starts out the numerator. That's a hint that there might be a negative factor in there. So when you see a negative starting out in the expression, try factoring a negative out. In this case, I'll write it as a negative 1. When I factor in negative 1 from negative x, I get x, and 3 divided by negative 1 changes the sign, so I get negative 3. Once I do that, I can clearly see that the denominator is the same as that factor that's left over when I take out the negative 1. So I can actually cancel these x minus 3's and get left with negative 1. Now, in the last examples involving functions, what we saw is it's always a good idea to say, if we cancel a factor like this out, that that's only possible as long as the factor that we canceled, which was x minus 3, is not equal to 0. So what this means is that x can't be equal to 3 in this case. That's a good thing to write into your final answer because it is a restriction on this simplification. You really can only simplify this problem to negative 1 as long as x is not equal to 3. This is called a domain restriction, as we saw in the last example. Let's do one more. X squared minus 12x plus 35 all over 49 minus x squared. In this example, we see that the denominator is not written in descending order. So I'll rewrite the denominator in descending order, negative x squared plus 49. The numerator is, so I'll just rewrite it as is. And then we want to try to factor. Now in the numerator, we've got a trinomial that will factor into the product of two binomials, x times x. And if you think about factoring 35, if you use 5 and 7, those will add up to 12, but we want a negative 12, so we'll make them negative. Negative 5, negative 7. Double check that, make sure it does work out before you go on. In the denominator, because it starts with a negative, factor out a negative 1 first. We have x squared minus 49. Remaining when we take out the negative 1. That x squared minus 49 is a difference of squares, so we can factor it further. The numerator is already factored, so it stays the same. In the denominator, we keep the negative 1 and factor the difference of squares. X squared minus 49 split up the x's, and the 49 splits into 7's, one of each sign. Now that it's factored, we can cancel the common factor of x minus 7. And we're left with this answer of x minus 5 in the numerator over negative 1 over x plus 7. Now, negative 1 is the same thing as writing just negative quantity x plus 7. And notice this is a case where you have the negative in the denominator. We could also put that negative in the numerator. So another alternate answer here would be to have negative x minus 5, we'd have to use parentheses there to put the negative in the numerator, over x plus 7. Or a third alternative would be to have the negative out front. Negative out front, x minus 5 in the numerator, and then x plus 7 in the denominator. If you have the negative out front of the fraction, you don't need parentheses in either the numerator or the denominator. So these are three ways we could express the answer. A fourth way, or a fifth way, would actually be to distribute that negative into either the numerator or the denominator, depending on where you have it. Most people would just leave it out front of the parentheses. So one of the things that can happen when you're working with rational expressions and simplifying them, is, especially when you have a negative factor, is that negative can show up in multiple places. So it's something to kind of be aware of, that maybe you write your answer this way, but the book shows the answer this way. There's nothing wrong with either technique. The main thing is recognizing when you have a correct answer. Just the negative's in a different place than maybe the answer key has it. In our third example, a minus b over b squared minus a squared, we have a numerator where the a comes first and a denominator where the a comes second. It's better to have that be in the same order. There's no descending order here, but put it in the same order. So negative a squared, I'm just going to write these in alphabetical order, plus b squared. Then we could factor the negative 1 because the denominator starts with a negative. Numerator isn't a factor, so I'll just keep it in parentheses. If I factor the negative 1 out of the denominator, I'll get a squared minus b squared, watch your signs. And then in the numerator, I have a minus b, and in the denominator, I can factor that difference of squares into a plus b times a minus b. And notice the numerator, a minus b, now has a common factor with the denominators a minus b, so those can be canceled. When you cancel everything from either the numerator or the denominator, there's always going to be a 1 left. So remember, when you cancel, there is a 1 left. So we have 1 over negative 1 times a plus b. And an alternate way to write that would be to write the negative out front or the negative in the numerator, your choice. I'll just show that one. I'm kind of running out of room. The last thing for both of the last problems that we could consider is this formal aspect of saying that it's only simplifiable if the factor that you canceled is not equal to 0. So in this case, what we canceled was a minus b is equal to 0. So that's I should say it can't be equal to 0, a minus b, so that means a cannot be equal to b. So one of the restrictions you might put in your answer here is that this is only true if a is not equal to b. And in my second example here, what we canceled was the x minus 7 at this stage. And if x minus 7 cannot be equal to 0, that means x cannot be equal to 7. So a final statement in our answer at the end would be to say that x cannot be equal to 7, whichever way you happen to write the answer. So these are called domain restrictions, and since we've canceled in the simplification, we should show what x cannot be equal to based on that cancellation.